Hello guys, welcome to Coding. In this video, we are going to see the Leetcode problem number 2225. Find players with 0 or 1 losses. Let's get into the problem. So, the problem statement is, you are given an integer array matches where matches of I, that is each match will be containing winner and the loser. So, yeah, winner and the loser. So, we need to return a list answer of size 2 where and the first answer should have two entities. The first entity is a list of all players that have not lost any matches. So the second entity is nothing but is a list of all players that have lost exactly one match. So the value in two list should be written in increasing order. So the values should be integers representing the player. Let's say each player has an ID, so the ID will be represented in the winner and the loser. So the values total should be written in increasing order, and there is some notes given here. So you should only consider the players that have played at least one match. So this is the case, and the test case will be generated such that no two matches will have same outcome. So these are all the problem statement. So let's get into the problem definition. And so the first step before solving any problem is nothing but to define the problem clearly. So the input is nothing but list of matches. So let's call it as matches array. So each entity will be having two. Each match will be having two entries. So it's a two-dimensional array. So the two-dimensional array, it's a matches, and output is nothing but to list. So list of list. So list of integer. So that is two in two list. So sorry, it's integer. So list of integer of size 2. So it considers as an answer. So this is what we are required to find out, and this is the input given. So what are the problem definitions? So now it's nothing but each match will be containing the IDs of winner and the loser each match. So this is the first statement, and the second statement is so there will be no match with same outcome. No match with same outcome, and we need to find the players that are having at least one match played. So only players with at least one match to be considered need to be considered. So is there any statement that is missing from this? So yeah, so the winner and loser, and we need to finally return the first list is nothing but yeah. So we'll say what are the output. So output will be containing, so let's say output is an answer. So answer will have two entries. The first entry is nothing but answer one, which is list of players who won every match. So the second entity is nothing but list of players who have lost only match. Who have lost only one match. So this is it. And any other statement? So we need to return the list in increasing order. This is another fundamental. So each list, so this answer 1 and answer 2 should be in increasing order. So both the lists should be in increasing order respectively. So yeah, we need to consider only if the player has at least one match. So players and no two match will have same outcome. So this is all about our problem revision. So now let's move on to our approach. So I delete this. So second step is nothing but the approach. So how can we approach this problem? So we need to find the condition for. So the answer is split up into two lists, right? So answer is split up into two lists, list 1 and list 2. So list 2 has players. So list 1 has players who won every matches, and he must have played at least one game. He must have played at least one game. So this is the condition. So he must have one. Sorry, he must have won at least one match. So this is the condition here. So the condition here, and the list 2 will be containing players. So it's players who lost only one match. So he must have, yeah, this is the case, and this is the condition for adding the player ID to list 2. So how can we determine which list should a player be added? So there will be player 1, player 2, player 3, etc. So how can we determine whether the player 1 goes to this list or this list? So there is only one possibility, and maybe the player may not be added to any of the list. So there are three possibilities. So what are the condition for player 1 to get added to list 1? So if a player is added to list 1, so let's say a player list 1 which is only one. So when the player is need to be added to this is a player. So when the player can be added to list 1, so when the player can be added to list 1. So the condition is nothing but the player has. So we'll consider this using a loss count or a win count. So each player will be having win count and the loss count. So this will be considering the two parameters to determine which list a player will be added. So list 1 will have only player which has one. So the player whose win count, let's say WC. So win count is at least 1 and lose count. So let's say LC is equal to 0. Only if this condition is met, the player can be added to that is the list 1, which is containing only players who has won every match. And what happens if we need to add the player to list 2, which is who lost only one match? Lost only one match. So when can this player be added to this? So we'll consider the two parameters. That is, the win count can be anything. So it may be greater than or equal to 0, and loss count must be 1. So when this condition is met, we can add a player to list 2. So there is another possibility that neither added to list 1 and neither added to list 2, that is nor list 2. So in this condition, all the exceptional case lies here. So when these conditions are not met, the other condition to be met is neither list 1 nor list 2. So will be the player will be added neither to list 1 nor to list 2. So when with the case in which this occurs is nothing but when the player won more than one game. So more than one game loss is nothing but loss count greater than 1. So in this case, neither the player will be added to list 1 nor list 2. So this is the approach we are going to use here. So our basic intuition behind this is nothing but firstly we need to find the win count and loss count of each player. So this is the main core logic of our approach. So the first step for our approach is nothing but find the intuition is nothing but find the win count and lose count so based on that uh, based on the win count and lose count add to respective lists. So this is the intuition behind this problem. So now let's find the steps to solve this problem. So next is the steps to solve the problem. So the first step what we are going to do is we are going to have a map of player ID, which is an integer, and integer to use to store the win count of each player. So let's call this as win counts, and second list is nothing but map of player ID, which is the key, and number of losses, which is an integer. So it is nothing but lose count. So we are going to create this two maps. So after creating this, so we are creating storing the win count and loss count. So store win counts and lose counts. So after storing this, we are going to check the condition. So check the condition and add to respective list. So as we have mentioned in the intuition, add to respect to list. So the condition I have mentioned it previously, so kindly check back. So you'll also know the condition in the coding section. So these are steps to solve this problem, and finally we'll add the, so we'll create an answer list. So that is a list of integer, before that we'll sort this to list. So unsort list. So finally we'll add the to list. So we'll call this as answer, and firstly we'll create and then add list 1 and list 2 to answer. So these are the steps we are going to follow, and the time complexities or space complexities are going to be discussed here. So time complexity is nothing but big of n, since we are going to iterate over each element. Maybe firstly we'll, in order to store in count and lose count, so this takes n time, and n, and store, yeah, this tool, this will contain 2n, and the checking for condition, so this will also take maximum play the size of the matches, so maybe it may be 2n, so this may be 2n, and finally list of so in order to sort this, it will take n log n, and yeah, so the time complexity of the approach is nothing but n into log n, which is n log n. So this is time complexity, and the space complexity of this approach is nothing but big of n, since we use only two extra spaces, and also there is a list, answer list. So this is space complexity, and the approach for this problem is nothing but hashing. So that's it guys, hashing, and also we'll consider sorting. These are the two approaches for this problem. So let's get on to the problem, get on the coding section. So there you'll get the clear idea of how to solve this problem. Yeah, let's move on. So the first step, so we'll go through each step. So first step, we'll create two maps. Step 1 is nothing but integer integer count. So the second step is nothing but to create a loose count. So step 2 is, step 1 and step 2 are here, and the step 3. So the step 3 is nothing but store win counts and lose counts. So we'll have a helper function, store win count, will pass win count function, list, and store lose count with lose count. Yeah, so the second step, and so we can reduce the step by using a single call. So store counts, and we'll pass the matches win count is, the map, and lose count map. So step 3 is finished into a single call, and step 3 is over now. So we'll check the condition and respond to the add to respect to list. This is the fourth step. So step 4. So what we'll be doing here is we'll iterate over each. So We need to create the to list. This is an additional step. So it's nothing but we'll get in the list of only winners, mm, like this, and we'll create new integer list of only one loss, new array list. We have created the to list, and finally we need to store the to list. I think, but firstly we'll try to add the players to only winners list. So for this, what we are going to do is we are going to iterate over win count. So nothing but so step 5 is nothing but we'll add the players to only winners list. So for this we are going to iterate our win count map. So for int player of win count dot key. So we are going to iterate over each key, that is each key will be containing player ID. So we are going to iterate over each player, and initially we'll get the win, let's say WC, which is win count. Win count is nothing but win count map dot get player, and lose count is nothing but lose count dot get our default player comma 0. So why we are using this is nothing but if lose count doesn't have a player, we'll store 0 as the number of games lost by the player. So what we'll do is if win count is, so win count will be having will assure that there will be at least one win by the player, so we don't need to check this win count. So we'll check whether lose count is 0. If lose count is 0, we can sure add the player to the only winners list, add player, or else we don't add. So step 5 is completed, and step 6 is nothing but, so we are going to iterate over lose count. So we're going to get the lose count. So lose count is nothing but lose count dot get our default of player comma here. So lose count will we don't need to have data default, because lose count will have it is lose count map is to be guaranteed to have lose count. So we just use get function, and for win count in, so we don't need the target the win count. So if loss count is equal to 1, we'll add to only one lose list. We'll add the player to that list, corresponding list, and we'll continue. So finally, we'll create the list of, that is step 7, nothing but to create list of integer answer values. So before adding the to list to answer, we'll sort the to list. So collection dot sort of only winners list, and collections dot sort of only one lose list, and finally we'll add the only winners and answer order only one loss, and finally we'll return the answer. So that's all, and we'll write the helper function which is store count. So store count will see the parameters matches and two list, two map. So map of, we'll copy this. First map is nothing but win count, and second map nothing but lose count. So we'll take up two maps and integer variable, that is 2D matrix which is matches. So for each match we use an enhanced for loop to iterate over each matches, and we'll take the winner. Winner is nothing but match of 0, and loser is nothing but match of 1. So we'll add wincount dot put um, winner comma win count. So win count of the current player. So win count dot get our default winner comma 0 plus 1. So lose count is same. So lose count is nothing but win loser comma lose count dot get or default of loser comma 0 plus 1. So what I have done here is in the two positions nothing but if the player is already added in the winners list, we'll get the count of the wins, and we'll increment it by 1. The same goes here. So we'll get the count of matches lost by the current loser, and we'll increment it by 1. So this is what we have done. So yeah, successfully done it. So let's check this up. So it's working fine. Let's submit it up. Accepted. And thanks for watching this video, guys. Have a great time.